Hello everyone. The task 2 is given as k-means clustering, in which we have to get the given iris data set and we have to predict the optimum number of clusters and represent it visually. For the first thing, we have, as usual from the task 1, we have 4 library functions, which are numpy as np, matplotlib as plt, pandas as pd, and cbone as sns. Also, we have sklearn import data sets. Loading the iris dataset, we have pd.readcsv as iris.csv. The output that we get on executing the iris dataset is the 4 subsets, which has length centimeter, width, petal length, petal width, centimeter, species. Getting the statistical information, we have iris.describe. This describes the proper length, width, petal length, petal width of the object. For example, we have count as 150, mean as 5, 3, 3.7, 1.19, STD as 0.8280, min as 4.30, 25%, 50%, 75% in max. Moving forward, we have to check for the data types, which is iris.info, which can also be further said as the data types that we get from sepal length centimeter, petal length centimeter, and petal width and sepal width. For this, we have not null values and we have float characters also. D-type float 64, object 1, memory usage is 6.0 plus KB. Moving forward, we have using pair plots or better understanding of the data plot distribution, in which we have graphs which showcase the species of the petals and the data, which is iris, and polarity, which is set 1. Following which we have 16 visuals iris setosa which are separable from the others. The red point shows the iris setosa, the green light shows the iris virginica, and the blue light shows the versicolor. Moving forward, we have sklearn.cluster import k-means. The k-means algorithm here describes the length width of the sepal and petal. Moving below, we have snippet shows how we can find the optimum number of clusters for k-means and how we can describe the value of k, for which we have again the sklearn import k-means, wcss, which describes the null set, for which I in range of 1 and 11, k-means gives n cluster and k-means plus plus. Plotting the results onto a line graph, we get a graph which moves from the higher point to the lower point. The title can be given as the algo method, and the x label 1 should be number of clusters, whereas the y label 1 will be WCSS. WCSS within clusters sum of the squares. Similarly, we can clearly see why it is called the algo method from the above tab, as the optimum cluster is where the algo occurs. This is when the within cluster of sum of squares doesn't decrease significantly with every iteration. From this, we choose the number of clusters as 3. Now in the plot 7, we have figure subtitle as k-means clustering. Here we actually start the programming where we actually decide the length of the petal and width of the petal, where we are giving features labels as 0 and petal width as 0. Here petal length as 1 and petal width as 1. 0, 0 and 1, 1 are the binary values which are put here. Next, we have drop-in labels. We only want to use features such as labels access 1 in place true. Similarly, the k-means clustering finally gives the 5 output, which actually showcases the blue, red, green and yellow lights of it, which directly gives the value of k as 1, 2, 3 and the original labels. The original label is the actual form of the length width of the sepal and petal. Applying k-means to the data, we finally come across visualizing the clusters in the first 2 columns, and hence we get the k-means clustering. Thank you.